All right, so I'm going to call this graphs of sine part 3 because we are still working on graphs of sine, but we will be finished today. And those of you at home, if you are in my second period class, we probably did this all in one day, but I'll post all 3 parts at the same time, depending on where we get. So today we are going to be graphing, still graphing sine, but we're going to graph equations that are in the form, bless you, y equals a times the sine of bx minus c. So we've graphed just y equals sine of theta, right? Y equals sine of x. We've graphed y equals a times the sine of x, which that when we had the a, that's changed our altitude. And then last class we learned about y equals a times the sine at bx, which we know if b is something other than 1, it's going to change our period, right? And so what's new about this is we have that minus c, okay? So when we have that minus c, we have what's called a phase shift, and that's what we're going to be learning about today. We also need to know this is where b must be greater than 0. Because you can't have a negative period. Okay, so a is still the amplitude, the absolute value of a. So I'm going to say the amplitude is still the absolute value of a. The period is still 2 pi divided by b. And remember, period tells you how long one complete cycle is. So if b is 1, our regular normal period is 2 pi, right? But if b is some number other than 1, that's going to change the length of the period, like it did yesterday. All right, so when you have a number in for c, that's going to change the location where one cycle occurs. So you know they've been starting at 0, 0, right? When we graph sine, it starts at 0, 0. So if we have a number in there for c, it's not going to start at 0, 0 anymore, okay? It's going to move somewhere. So let's make sure we take good notes here. You take good notes and you read your notes, it's going to be a lot less confusing than if you don't. So when we have a value for c, this will change the coordinate where the cycle will begin and end. To find that location, solve the following inequality. Which is 0 is less than or equal to bx minus c is less than or equal to 2 pi. As we know in a parent function, our period is 2 pi long, right? It starts at 0, it ends at 2 pi. That's just for a regular sine function that where b is 1. So, well, if we have bx minus c instead of just the normal 1x, okay, it's going to start and change at a different place, or start and end at a different place. So what I'm going to do is I'm going to get x by itself. So the first thing I'm going to do is I'm going to add c to all parts of the inequality. Oh, I put a 3. I meant a c. That's a c. Very messy c. So 0 plus c is less than or equal to bx minus c plus c is bx is less than or equal to 2 pi plus c. I am trying to solve for x, okay? Solve for x. So is my x all by itself? No, now what should I do? Divide each part by b. So divide this by b, c divided by b, 2 pi divided by b, c divided by b. So that gives me c divided by b is just c divided by b. Is less than or equal to bx divided by b is x. Is less than or equal to. I can just rewrite that as 2 pi plus c quantity divided by b. Okay, great. Well, what does that mean? So our normal period, your x values are between 0 and 2 pi, right? You have a value in for c. Your starting point on the left side is going to be whatever c is divided by b. Your ending point is going to be 2 pi plus c quantity divided by b. So, always. So this is the x coordinate. Where the cycle will begin. I'm going to put left side in parentheses. And then this is the x coordinate where the cycle will end. I'm going to put right side in the parentheses. Or really, I don't even use the right side. I use some different kind of math to figure that out. But if you wanted to know the ending point, you could do 2 pi plus c divided by b. But most importantly is that c divided by b, okay? The c divided by b is what we call the phase shift. So if you were just asked, what is the phase shift? Take your c divided by b, and that's the phase shift. Of course, we'll write that down. I know I'm writing a little fast, so I need to wait a minute. Some yes, some no. Oh, wait a second. Okay. The c divided by b is called the phase, P-H-A-S-E, shift. It means the graph is shifted horizontally by c divided by b. Coolio? So what does all that mean? Well, we're going to do an example. Am I still writing? Have a question so far? Yep, okay. We good? All right, so we're going to graph y equals 4 times the sine, open parentheses, 2x minus 2 pi over 3. So this is in the form y equals a times the sine at bx minus c. So my a is 4. What's your b? 2. What is your c? It looks like it's negative 2 pi over 3, but right, it's positive because the formula subtracts c. So if c was negative, you subtract a negative, it will look positive, right? If c was positive 2 pi thirds and you plug it into the formula, it's going to look negative because the formula subtracts it. So you got to be careful about that. We'll make a note of it in a minute. All right, so what is our amplitude? 4. What if there's nothing in a spot? What's your amplitude? 1, okay? We got to figure out what the period is. So remember yesterday we learned if b is some number other than 1, your period's not going to be 2 pi, right? So our b is some number other than 1, it's 2. So to find a period, you do 2 pi divided by b. So in this case, that would be 2 pi divided by 2. What is the length of one period? Pi. So say I wanted you to graph from 0 to 2 pi. Say it started at 0. I want you to graph to 2 pi. How many cycles could we get in there? 2. Okay. But we know we're not going to start at 0. So we are going to start at whatever our phase shift is. Because we have a number in there for C, we're going to have a phase shift. So to find the phase shift, you can find the starting and ending place if you want to. I'm going to end up finding it a different way, but I do use the C divided by B to find the starting point, the left side of one cycle. So that's going to be C divided by B. So we said C is 2 pi over 3. The sign is different than what it looks like. I'll make a note about that in a minute. Quantity divided by what? 2. I'm going to say notice 2 pi over 3 is not negative. The formula changes the sign of C. All right, don't we have a complex fraction here? We don't want a complex fraction. What can we do to get rid of that? Multiply by 3 the numerator, each term in the numerator, and each term in the denominator. So what's 2 pi thirds times 3? It'd just be 2 pi, right? Because the 3's will cancel. Denominator, 2 times 3 is 6. Can I reduce that to what? Pi thirds, right? Pi thirds. This tells us the phase shift, meaning the cycle will start at pi thirds instead of at 0. This tells us the phase shift, meaning the cycle will start at pi thirds instead of 0. All right. I know y'all are really good at taking notes, thank goodness, because we got a lot of notes to take on this one. Okay, so since the cycle starts at pi thirds, since the cycle starts at pi thirds, we have to figure out where our main x values will be. You know how we divide it into fourth? We divide our cycle into fourths. So I want to know what each one of those little 1/4 ticks are. Out where our main x values will be. So since the period is pi, divide the period by 4. Do you know how we have it in 4 equal sections? To get pi fourths. So 1/4 of the way through is going to be pi fourths long. Pi fourths long, pi fourths long, pi fourths long. You add pi fourths, pi fourths, pi fourths plus pi fourths, you're going to get 4 fourths pi, which is 1 pi, right? All right. So we will add pi fourths to find each x value of the main points on our graph. And that's going to mean we're going to have to do some adding of fractions, which I know you all know and love, fractions. All right, so I'm technically finding 5 points because I have my starting point, then you have the 3 in the middle, and then you have the ending point, right? So technically that's 5 points. Do we know what our starting point is? What? Pi thirds, right? The phase shift is pi over 3. That's our starting point. So let me kind of just go ahead and start with a little graph here. And what's our amplitude? 4. 4, 3, 2, 1, 0. So I know my graph is starting at pi thirds. I'm just estimating where that is. And so one complete cycle is going to be separated into 4 equal parts. I only know the first one. But I know each of those sections are pi fourths in length, right? Because we took pi and divided it by 4 to figure out how long each of these segments were. So I got to figure out what is each of these segments, because I got to be able to plug it into my table of values and do the math, which we know what the graph's going to look like, right? We already know. But like I told you last class, this is also teaching you how to solve trigonometric equations, okay? So it's not just memorizing what the graph's looking like, it's also knowing how to solve the equations. So let me find my 4 points. I know my first point, I'm going to call it x sub 1. I know that starts at x sub 3. And I could find the 5th point by doing 2 pi plus c quantity divided by b, what we wrote on the other side. But I don't actually do that because I got to find them all anyway, so I just do the same thing to find each point, okay? So to find my second point, I take my first point, which is x over 3. I wrote x over 3. I'm sorry, I meant pi over 3, not x over 3. Pi thirds. And I'm going to add pi fourths to that. And that will give me where the second point is. Pi thirds plus pi fourths. So when I do the math, I'm not going to do pi thirds plus pi fourths. I'm going to say 1/3 plus 1/4. Okay, I'll do that over on the side. 1/3, and we're not turning it into decimals. When we add fractions, we need a common denominator. Least common denominator is best. So what's the smallest number that 3 and 4 divide into evenly? 12. So we have to make equivalent fractions. 3 times what is 12? 4. So 1 times 4 is 4. Does 4 twelfths reduce to 1/3? Yes. Okay. Look at 1/4. My denominator went from 4 to 12 using multiplication. 4 times what gave me 12? So 1 times 3 is, does 3 twelfths reduce to 1/4? Okay. So now we can add. 4 plus 3 is 7. You do not add the denominators together. So our second point is going to be at 7/12 pi. You can go ahead and label that if you want. 7 pi over 12. Y'all cool with that? So to find my third point, I'm going to take my second point and add what to it? Pi fourths. Because each of these segments are pi fourths long, right? Because we took the length and divided it by 4. So basically we're doing 7/12 plus 1/4. 7/12 plus 1/4. What is our least common denominator? 12. So 7/12, the denominator didn't change, so the numerator won't change. 7/12 equals 7/12, so that's true. 1/4, 4 times what gives me 12? 3. So 1 times 3 is, does 3 twelfths reduce to 1/4? Okay, so 7/12 plus 3 twelfths is 10 twelfths, and I can reduce that, so I'm going to. What does 10 twelfths reduce to? 5, 6. So I'm going to say 5 pi over 6, or 5/6 pi. That's going to be halfway through. Coolio? All right. Let's find our fourth point. So I take the third point, which was 5 pi over 6, and I add pi fourths to that. Because we're just going 1/4 of the way up each time. Plus 1/4, plus 1/4, plus 1/4, plus 1/4. So I'm going to do 5/6 plus 1/4. Do I need to explain in more detail how to add these fractions, or are we good? Okay. So what's my least common denominator? 12. So 5/6 will equal what? 10 12. 6 times 2 is 12. 5 times 2 is 10. 1/4 will equal what? 3 twelfths. 3 twelfths reduces to 1/4. So 10 twelfths plus 3 twelfths is 13 twelfths, which will put a pi with the numerator. So 13 pi over 12. So I'm going to go and label my graph 13 pi over 12. That's the second to the last point, and they can't see it on the screen. To find my last point, Again, I could do 2 pi plus c divided by b, but since I'm already doing it this way, I'm just going to find it this way. Does that make sense? Okay. So I take my last point, which was 13 pi over 12, or 13 12 pi, add a quarter pi to it. So 13 12 plus pi fourths, do my math up here. 13 12 plus 1/4. GCF is 12. So 13 12 won't change. 1/4 equals what? 3 12. 3 12 reduces 1/4. So that is 16 12, which I can reduce that. What goes into 16 and into 12? The largest number. 4 divides into 16 4 times, 4 divides into 12 3 times. So we will call that not just 4/3, but 4 pi over 3, or 4/3 pi. And that will be my last point. Now, if I would have done 2 pi plus c divided by b, I would have gotten the same thing. It's just going to take me a little bit more work. That's why I just go this route. But to find that first point, you do have to do c divided by b. Now, I know we know where it's going to start, but we're going to do the math. I'm going to have to do my math on a separate sheet of paper because I'm out of room. All right, so I'm going to make a t-chart. On my t-chart for my x values, I'm using pi thirds, 7 12 pi, 5 6 pi, 13 12 pi, and 4/3 pi. Okay, y'all with me? And I'm going to give myself plenty of room because I kind of have quite a few steps here. So I'm not going to label all my x's yet. So that way I'm not limiting myself on my room. I am going to draw, of course, a little unit circle. And I'll start at pi thirds. So when x is pi thirds, that's y equals 4 times the sine of, open parentheses, 2 times pi thirds minus 2 pi over 3, or 2/3 pi. Well, isn't 2 pi over 3, or 2 times pi over 3, isn't that 2/3 pi? So do what's in your parentheses first. What's 2/3 pi minus 2/3 pi? 0. So basically, I'm going to find the sine of 0 first, which the sine of 0 is 0. So 4 times 0 equals 0. So at pi thirds, I'm going to plot a point at 0. I knew that was going to happen. So we're not starting at 0 0 here because there was a phase shift. We're starting at pi thirds. At home, I have, oh, there we go. So it's taking forever to get the graph up. Pi thirds, I plot a point at 0. And then I'm going to do the math for 7 12 pi. So we have y equals 4 times the sine of 2 times 7 pi over 12 minus 2 pi over 3. So that's y equals 4 times the sine of, what's 2 times 7 12ths? 14 12ths, right? So 2 over 1 times 7 over 12 is 14 12ths, which reduces to what? 7 over 6. So I'm going to put 7 pi over 6 minus 2 pi over 3. Y'all cool with that? Now what part do I do next? I gotta subtract the fractions. So over on the side, I'm gonna do 7/6 minus 2/3. And what's my least common denominator? 6. So 7/6 equals 7/6. And negative 2/3, what will I convert that to? Negative 4/6, very good. So 7 minus 4 is 3, 6, which we will reduce to 1/2. But it's not technically 1/2, technically it's pi halves, right? We didn't bring our pi into our math over here. So y equals 4 times the sine of pi halves. And what is the sine of pi halves? 1. So y equals 4 times 1. What does y equal? 4. So on your graph at 7/12 pi, plot a point when y equals 4. Will you, Donald, tap him on the shoulder? All right, y'all cool with that? So now we're looking for 5/6 pi will be my next point in my table. 5/6 pi. Do y'all want me to do that out loud, or do you want to try to do it on your own? All right, try to do it on your own. I'll be working it too, but don't look up unless you have a question or you just want to check just to make sure you're doing it right, okay? Mm-hmm. 2 times 5, 6. Because a lot of times with kids will do 2 times 5 and 2 times 6 when it's should be 2 actually has a 1 under it, you know. Mm-hmm. So if you got that one right, go ahead and complete the other points, and then we can compare. So for 5/6 pi, my y was equal to 0. And I'm just going to do the other two quietly. I want you to do them too. Just make sure, check along the way. Did y'all get what I got? Any questions about either of those? Okay, so my graph should look like this. We already said the amplitude was 4. We already said the period was pi. What is the domain? Negative infinity to positive infinity. What's the range? -4 to +4. We use brackets because they're both included. And is it a vertical stretch or a shrink? Stretch by a factor of what? 4. Now, our period was supposed to be pi lengths long. One cycle was 1 pi. So what is 4/3 pi minus 1/3 pi? 3/3 pi, right? 4/3 minus 1/3 is 3/3 pi, and 3/3 reduces to 1 pi. So is that pi lengths long? Yeah. So we started at pi thirds. That's our phase shift. We ended at 4/3 pi. And that should be one cycle is the length of 1 pi. Okay. So all we did was just graph that if we went counterclockwise, just the first half of the circle, 0 to pi. Are we cool with that? Okay, I've got one more to do and then I'm done. So our assignment on graphing will be tomorrow. I'm gonna have to speed this next one up because I have like, I don't know, 10 minutes. Yeah, can you get it to, can you get it after the next problem? Just because I want to make sure I get the whole next problem in before the bell rings. Okay, you're welcome. All right, so we're going to graph. Y equals 1/2 sine of x plus pi. All right, what is my amplitude? 1/2. What is my period? Right, so what's b? 2 pi over b, and you're right, this time b is just 1, right? There's no coefficient of x. Well, there is a coefficient of x, it's just 1. So our period will just be the normal 2 pi. Since coefficient of x is 1, the period won't change, okay? Only if there's coefficient of x. All right, our phase shift, since we have a value in for c, we have to figure out, we're not going to start at 0. We're going to shift either left or right. We got to figure out what that's going to be. So to find our phase shift, we will do c divided by b. Remember, this is a, b is the coefficient of x, c is pi, or the whatever is being added or subtracted to x. So in this case, what is c? Is it pi? It's negative pi. Remember, you got to change the sign. Don't forget. Change the sign of c. Very important. Divided by, what was b? 1. So b is the coefficient because it's bx minus c, right? A times the sine of bx minus c. B is the coefficient of x. C is whatever is in being added or subtracted to bx. Which was 1. Why did I write b? So negative pi divided by b. So my phase shift is at negative pi. So where is my graph starting? Or my cycle, negative pi. This is where the graph will start. So this time my cycle is 2 pi long, not just pi long, okay? So am I going to add pi fourths to each point to find the next point? No, because it's not my cycle, my period is not just pi anymore, right? So divide the period by what number? 4, because it's 4 equal sections, right? Divide the period by 4 to figure out the distance between each x value. So my period is 2 pi. Divide that by 4, which is pi halves. That will reduce to pi halves, exactly. How cool with that? Okay, so I'm going to find, do we know our first point? Negative pi. So I'm going to call it x sub 1. X sub 1 is negative pi. All right, so my second point, I take negative pi and I add what to it? Pi halves, and that will give me my second point. So just add the coefficient. So that's negative 1 plus 1/2, right? And I'll do that on the side. Negative 1, I'm going to turn that into a fraction. So negative 1 over 1 plus 1 over 2. My common denominator is 2. So the plus 1/2 won't change. Negative 1 over 1 is equivalent to negative 2 over 2. Is that right? Okay. So negative 2 plus 1 is negative 1 over 2. But we got to make sure we put pi in the numerator. So that's going to be negative pi halves. That will be my second point. So my first point is negative pi. Add pi halves to it, you get negative pi halves. Third point, I'll take my second point and add pi halves to it. Well, what's negative pi halves plus pi halves? 0, so that's my third point. Fourth point, how many points are we finding? 5. So take my third point, 0, add pi halves. 0 plus pi halves is pi halves. To find my fifth point, take my fourth point and add pi halves to it. Well, pi halves plus pi halves is pi. We didn't even have to do very much math on that. All right, so our graph's going to look a little bit different than we're used to because we've never started in the negatives before. So I'm going to have, our amplitude's very short, but I'm going to have parts to the left and to the right, okay? My amplitude is at 1/2. And the left side starts at negative pi. The right side ends at positive pi. So here's the whole period. Here's the middle part. And then just separate that. I need the 2 more sections. So start at negative pi. Then I'm at negative pi over 2. Then I'm at 0. Then I'm at pi halves. And then I'm at pi, which I already said. So we already know at negative pi what your x, your y value is going to be. We know it's going to be 0, but we're going to do the math anyway because we need practice solving trigonometric functions. So I'm going to do all that at the bottom. I want you to do it on your own. I'm going to kind of do it quick because it's 11:17, and you know the bell rings at 11:19. So I'm going to do it quick. You do it on your own, and we'll come here.